Hello everyone. I'm Andy from ThinkMo. I'm teaching CCIE courses now. As of today, I'll share some with you. Technology related to CCNA, CCNP, and CCIE. Our topic today is PPP links. The IP addresses at both ends are on different network segments. Whether the communication can be realized. We need to know what is PPP. PPP is called point-to-point protocol. First of all, you need to pay attention. It is a link layer protocol. It is mainly used for full duplex synchronous links. At the same time as it. For example, the X.25 line or frame relay. FR the frame relay environment. Similar to X.25 or frame relay. This early low-speed line. The bandwidth is small. It has been eliminated. So why does modern PPP still exist? For PPP, it has some advantages. So where does it show up? We can look at it through this introduction. The first one is the one we just talked about. The second is that it has good scalability. Scalability is mainly manifested in Ethernet links. What we use today is called Ethernet. To carry the PPP protocol. Encapsulate PPP. In this case, combine Ethernet and PPP. PPPoE is formed. PPPoE, maybe you don't often listen to it. But you've heard of broadband dial-up. Such as broadband. The operator will then give you a broadband account. And they'll give you a broadband code. Then enter the broadband account number and password. Input to the TP link. We're talking about routers like the 360. Enter to achieve the dial. Then you can go online. This is the PPPoE we mentioned. So why use it with Ethernet? It's very simple. There is something on PPP. You can't do that with Ethernet. For example, as we mentioned, the LCP protocol. It involves the link control protocol. Is used to negotiate various link layer parameters. So it could be on this one. What are the things that are negotiated on the link? It can negotiate what we call the MRU. It's also called MTU. Maximum Transmission Unit. And the MRU is called the Maximum Receiving Unit. What do we mean by transmission unit and receiving unit? It's a one-time thing. How much data can be sent? Let's say I give out 100 at once. Then you can only receive 12 at a time. You can't take it like that. That's what we're talking about. Negotiate the maximum receiving unit MRU. The second parameter is one way to authenticate. What is the method of certification? Is what type of authentication we use. Let's say it's in plain text or ciphertext. In the PowerPoint, there are two main types involved. One is PAP, which is called plain text authentication. This chap is called ciphertext authentication. For example, let's set a code word. And then you answer the next sentence. This is equivalent to plain text. Ciphertext is like the telegraph of the early war years. Each side has its own code book. And then they split out their data. And then we show it in other forms. Which means the transmission is ciphertext. The ciphertext was altered. And then you have to have a code book before you can put it back together. In this case we call it ciphertext. That's what we're talking about. The concept of authentication mode. And then the next and then the next. There is no retransmission mechanism behind it. Low network overhead and high speed. We're not going to explain it too much. These are the aspects that we mentioned. The LCP contains only these two parameters. There is another important parameter. It's called modulus match number. It is mainly used to prevent loops. How do you prevent loops? On a PPP circuit, point-to-point is the connection between the two. There's no other equipment in between. Such a circuit, it can be regarded as a PPP link. In this case, sending a piece of data. I wonder if there's any chance you could send it back. What should I do then? For example, the number 1 is generated locally and randomly. If you generate the same number as 1. So in the message that I'm sending, I'm going to send you the 1. After receiving it, it's exactly the same as the locally generated 1. That's when you think you have a loop. It's only the same in one case. I just generated a 1. I send it and I send it back. I carry 1. You sent it with a 1. In this case, we think of it as a loop. So the modules generated by the two devices. It's definitely different. Let's say you generate a 1 and I generate a 2. This circuit can be set up normally. Negotiation of link layer parameters. There are 3 main ones involved. MRU, authentication mode, modulus. All 3 have different functions. Next up is a protocol that provides various NCPs. We're only going to talk about one IPCP here. IPCP is used to negotiate IP addresses. How does it negotiate? Let's say 2 devices connected on a PPP circuit. This interface is configured with an IP address on both sides. This will be in the NCP protocol. It uses IPCP and then negotiate. I send a packet during the negotiation. Give me my IP address. For example, 1.1.1.1, put it on. Send it to you. You'll be sending a message, too. Give me your IP address. For example, 2.2.2.2, send me. Then we receive the packet from other party. For example, I'm using 1.1.1.1. This time you received after. Would you check? The IP address of the interface is the same as mine. If the same, then a rejection message will be sent. If the IP addresses are different, then an ACK packet is sent. Acceptance on behalf. The IP address used is fine. If the address is a duplicate, there will be no ACK. Because of the address conflict, both use 1.1.1.1. It's definitely not possible. Let's say these 2 devices. You are using 1.1.1.1. I use 2.2.2.2. That's okay. If you send request indicates the request packet. It replies with a confirmation message. You can use 1.1.1.1 for 2.2.2.2. The same is true for this address. You send it to 2.2.2.2. I'll have a look at it when I get it. Mine is 1.1.1.1. You're using 2.2.2.2. So that's okay. And then the negotiation is done. It is not enough to conclude negotiations. One more thing we need. You have to have a route. What does routing mean? For example, AR1 and AR are 2 devices. I want to go to AR2. I need access to AR2. Route map of IP addresses. This road map is what we call a route. You need a route if you want to send it to me. So AR1 has to have a roadmap to AR2. AR2 has to have a roadmap to AR1. How do you get the route? Once negotiated through the NCP, the first device knew IP address of the peer party. The second device also knows the IP address of the other device. Then it'll be local at this point. Automatically generates host routes. Host routing is 2.2.2.2 and 1.1.1.1. The mask is 32-bit. So we think of it as a host root. It's like a mainframe. We can make it easy. Take a look at host routing. We can see that. Now on this device, the AR1, a 2.2.2.2 is generated. 24. The next hop is the next hop. Just where to send it next. Sent to 2.2.2.2. It's going to generate this route. The same is true on AR2 devices. A 1.1.1.1 will also be generated. 32. That means you have a route. The IP address negotiation is completed. This link is passable. The protocol of the link path is called LCP. And then the negotiation is done. These parameters are also complete. Next, AR1 goes to ping 2.2.2.2. They can communicate with each other. So that's why, for the purposes of this lecture, IP addresses of both ends of a PPP link, different network segments, can communicate with each other, mostly through NCP, the IP address in it, to negotiate the IPCP. In the NCP negotiation phase, the IPCP protocol is used to negotiate IP addresses. In the meantime, it will be local. Generate a peer interface. IP address of the host route. So you have communication. That's all for today. If there are any other skills you would like to learn, feel free to leave a comment or send me a private message. If you're interested in what I'm talking about, hope to like and subscribe more. Thank you. See you next time.